Hello, everyone. In this video, I will share with you point cloud data visualization. We all know that the common standard format for point cloud data is LOS. It records the complete information of a point cloud data, including two parts, the head file and the point record. Each point record contains the complete attribute information, including X, Y, Z coordinates, echo number, RGB, GPS time, class, etc. Among these attributes, the category is one piece of information that is particularly critical. Common numbers correspond to categories as follows. 1 represents unclassified points. 2 represents the ground point. 3 represents low vegetation. 4 represents medium height vegetation. 5 represents high vegetation. 6 represents the building. For other category information, please refer to the description file in LOS format. Therefore, we can visualize the point cloud data in the following ways. We can render by elevation. Can be rendered in accordance with the intensity of reflection. Can be rendered in RGB shading. Can be rendered according to the number of echoes. Of course, you can also render by category. At the same time, we can also combine the two attributes to enhance rendering. For example, here we can fuse reflection intensity information with elevation information for enhanced rendering. Next, a specific example is combined to demonstrate. When we open up a point cloud, in this open dialog box that pops up, the user is then asked to select the attribute information of interest. The default attribute information includes color, classification, source, return number, number or returns, intensity, and so on. Users can select relevant attribute information according to their own preferences. Click the OK button. During the reading process, the total number of points contained in the entire point cloud data is counted. Well, with this data, let's take a look at how to visualize point cloud data in PCA Viewer software. The return by elevation of the toolbar menu is rendered according to elevation. We click on the tool. The user can choose the corresponding elevation color scheme. Our software provides 11 elevation color schemes, and users can choose the appropriate elevation color scheme according to their preferences. These 11 color schemes are all classic color schemes. For elevation, we can also render according to the color cycle. Render by banding. This tool lets you specify the elevation interval to set the color cycle. This method is more suitable for checking digital elevation models. At the same time, Render by Class is a tool that enables browsing point cloud data by category. There is also a Browse by Category. We can also select only the categories we are interested in to browse. For example, in this data, we only look at the ground points. Low vegetation, medium height vegetation, high vegetation, and buildings of interest. We can also render according to the RGB color of the point cloud data. It should be pointed out here that not all point cloud data has RGB information. In addition, we can also visualize the point cloud data according to the reflection intensity. The reflection intensity is an attribute feature that effectively distinguishes different types of ground objects. We can also visualize the point cloud data according to the number of returns. Since the area of this data is relatively large, let's take a look at its partial profile. Let's draw a section to take a look. The echo information shown in this profile has an echo, secondary echo, 3 echoes. At the same time, we can also perform visual rendering of data according to point source information. Point source information often corresponds to airstrips information. We can clearly see that this point cloud data consists of 3 airstrips. And there is significant overlap between the airstrips. If the user is only looking at the point, we can render it in the Render by None manner. In this display mode, each point is displayed in a grayish-white. As mentioned earlier, we can also perform fusion rendering display. We can click Render by Fusion of Height and Intensity this tool to fuse and render the elevation and intensity information. This time also requires us to specify the elevation color scheme of interest. If the user is not satisfied with this elevation color scheme, another color scheme may be selected. In addition, our software also has some unique display. For example, if we segment individual trees, divide the single house, then give each tree a color, and different trees give different colors. This is the visual rendering of the data according to the segmentation number attribute. At the same time, our software also has one special visualization schemes for point cloud data. From the raw point cloud data, we calculated a feature of stereoscopic perception. Blends the stereoscopic perception with the elevation. In this way, when users browse point cloud data, not only can see the elevation information, and also can see more three-dimensional information. Next, we will show you a case. Click the Render by Fusion of Height and 3D feature in the toolbar to visualize the point cloud data. In this mode, we can not only see the elevation difference of point cloud data, but also see the three-dimensional sense of point cloud data. Of course, we can also add the reflection intensity. We can see that there is still a little change before and after. This feature incorporates both elevation information and inverse intensity information, as well as stereoscopic perception information. We can also fuse rendering of categories with this stereoscopic perception. In this mode, after the fusion of category information and stereoscopic perception, the entire semantic information is also enriched. Let the user experience more intuitive, more three-dimensional category information. In our software, we can also perform visual rendering of point cloud data according to this segmentation number attribute. That is, the ID number of the object. Here we can also select an entity, an object, to look at the specific situation of the object. At this time, if you press the Shift key, you can make multiple choices. For airborne/UAV laser point cloud data, not all trees contain trunk information in the acquisition of forest point cloud data, or the bottom of the tree canopy, which may not have relevant vegetation information. Therefore, in many cases, a single tree often only has the data of the crown part. You can contact us by email at jonas_zinc@gmail.com or WeChat at +86 1388837 1238. Alternatively, you can obtain a trial license by filling out the relevant information on the website https://www.thjymap.com/pca. Thank you for watching and see you next time.